All right, so we are out in the Runnymede neighborhood, kind of east of Davidson, and this is the spot I've been coming for years to look at the stream. The west branch of the Rocky River comes through here. It has been raining for 2 days associated with the tropical storm, former hurricane known as Delta, and so there's just a few good things we can look at that we've been talking about in class. So we're gonna start here looking at some rocks. This used to be called Egg Rock Woods back in the day, and then I think some Davidson students in the 60s rolled the rock called Egg Rock down the hill. And now it's called Whale Rock Woods to a lot of people. It's now private, so it's a little harder to get to. So we'll look at that. It's a good example of differential weathering. And then we'll look at the stream here and look at some of the setups we were talking about. Now I assume that the river is going to be pretty high because it's been raining so much, so that may put us off a little bit. So I'm actually coming up on the river right now, so we'll walk over there and I will look down at the river and we'll see what the level looks like. We'll go from there. Let's see. Pretty brown. All right, let's take a look around. Impressive, really. These are pretty big. I mean, that's a big slab of rock for around here where you don't see much rock in the Piedmont. I've historically thought about these things kind of as mini monadnocks, right? Like something about the mineralogy of these has driven them to weather differently. And I still think that's probably true. But I think there's another thing, because most of these in the Piedmont lie along the rivers. And so I think there's probably another component, which is that these river valleys are probably younger than I think they are in terms of geology, at least. And so if these river valleys formed within the last 100,000 years, you'd get pretty rapid downcutting. I know that's a long time, but geologically not so much. And so as you get that downcutting, these things would kind of get exposed along the banks of the river because the weathering can't keep up. Because once you've started physically eroding things, the chemical weathering isn't going to go nearly that fast, but hard to say. I think it's probably a combination of the two. All right, here we are up on top. Nice little view into the woods here. Slippery. All right. So it's hard to tell in the wet. There's a lot of moss on it now. But it's also quite black in color. And I think that dark color is almost all manganese. Around here, manganese can get kind of fixed to the surface of the rock by bacteria that consume it, and then as they excrete it, they kind of fix it to the surface of the rock. So when it's drier out, you can actually see where water pools because there's more manganese there. When it looks like this, it all kind of looks the same. We got some lichen here, this kind of light green lichen here. All right, so that's the rock around here. That's one of the bigger ones. There's a handful of them in the area. There's a big set that's longer, not too far north of here, but it's on completely private property. And there's lots of little ones here and there. So, okay, let's go down and take a look at the river from here. We'll see what's going on down there. Okay, so there's a lot going on here behind me. So I've spent a lot of time over the years talking about the way that Piedmont streams are cut down into their beds, and we call that incision. So, you know, right here, I'm right at the edge of the river, and yet I'm probably a full 3 meters up above the river level. And so all that is due to incision from the river and down cutting. And the interpretation around here has been that that's probably not natural, including some work of my own. So lots of students of mine over the years have come out to this river and dug into the banks along the stream to try to figure out what's going on. In fact, even from just standing right here, I can see 2 or 3 places that we've dug in the past. There's one across the way. It's not very clean right now, but if you look right over here, you can see some spots where we've dug in the past. And part of that is putting a paper together similar to the Dearman and James paper that we're reading in class, where we went through and described all this material. And what we find is that the bottom half of these walls, and I would normally just jump down in and show you, but with the water high, there's no benches to stand on. But the bottom half looks like very natural sediments deposited as part of a floodplain and kind of a grading or building up. And then the top half of the sediment in the wall is all very sandy sediment, and the few radiocarbon dates we have out of that sediment would seem to indicate that it all came post-Euroamerican colonization. So when we look at the Spell and Johnson paper and we're thinking about those gullies and where did all that sediment from the gullies go, one interpretation has been that all that sediment from the gullies is actually sitting here on the banks of the stream, having piled up relatively recently. There's a lot of other human impacts going on here too. I'm standing on the side here on a little pile of dirt. And this pile of dirt, if you dig into it, looks like it was just plopped here. And having talked to enough farmers around here, I think it probably was plopped here, because another reason that these streams are cut so deep is that people just manually straighten the streams with backhoes as late as the 50s and 60s in order to get the water level lower. And in getting the water level lower, excuse me, you could drain these lower fields like where I'm standing better, and they'd be better for planting. So that means this surface that I'm standing on here that's kind of flat and about 3 meters above the river, if you look behind me, and this little trail is on, that is probably the pre-colonizer floodplain. So this river would have been way up here and would have had access to this floodplain. It would have wandered back and forth across it, and now it's very channelized and stuck in the bottom. Another thing, and I can't believe we're not reading this paper because it's kind of a classic for the East Coast, but there's another thing going on in here too, which is that this pile of rocks on the other side is actually an old dam that was abandoned. And there's been a lot of work done in the last 15 years talking about the impact of these small dams on creeks in the United States and then elsewhere. The seminal work on that was done in Pennsylvania, rural Pennsylvania, by people at Franklin and Marshall. And so we've learned a lot about that. That could also be a cause for the incision here, which is that the idea being that you build up this dam here, right? And then you have a little pool of water here, a small reservoir, right? And that builds sediment up behind it. And then when the dam inevitably breaches, as it's done here, then the stream would cut down through that sediment. Now the problem with that is that I've looked at the sediments here and they don't match the sediments of a small pond. And the other problem is that if we go down below the dam, it's just as in size below the dam, which it shouldn't be. So anyway, there's a lot of reasons I've spent time at this site. There's a lot of reasons my students have spent time doing research at this site over the years. It's definitely an interesting spot, and so it's worth coming out to while we're here. Okay, so we're coming back up to the bridge, a spot where we've already stopped and talked. But I did want to mention one other thing. One of which is just, now that we've talked about incision, this is a great place to look at incision. So let's do a little panorama here. And so if you see the flat, which is these horse fields over here, right? That flat material is the old floodplain. and it's kind of been abandoned up here. And then this is cut down into it, so I'm going to scroll across. And then again on the other side we see the floodplain again, right? So you can really tell that. Now, this is kind of a little flood stage here from Hurricane Delta. And so if one of you was here, one of you would probably ask me how high this water gets. And while I wouldn't still consider this a floodplain, water can reach up there in extreme events. So if we got a bigger hurricane through in about a month when all the leaves are off the trees and evapotranspiration was really low, water can come up and reach its old historic floodplain, but it takes quite a special event. The bridge that I'm standing on right now has been destroyed in the past, so the water can get high enough here for this bridge to get wiped out, and obviously that would be quite a powerful storm. So, all right, let's go over to Fisher Farm, and we will take a look at some of Roz's gullies, and you'll get to have an idea what those look like. Here we go. Okay, so we are at Fisher Farm, which touches Abersham, and you guys have read the Spell and Johnson paper, so you can look at the map and kind of get an idea of where I am, because lots of Roz's gullies are either here or at Abersham, basically. And then the rest are in the ecological preserve, which you guys may or may not have some knowledge of too. So I'm on one of the main hiking trails. One of the convenient things here is that these hiking trails kind of walk along contour, and so they cross a bunch of the gullies. So you can kind of see, it's hard to see in the woods here, especially this time of year when the leaves are still on the trees, but you can see these little drainages that come down, and some of them turned into gullies and other ones didn't so much. So we're gonna walk a little bit and then we'll take a look at a couple of these. One's not too big, but there's definitely one here, and you can see kind of the head of the two sides of it up here, and then it comes through right through here and down and out. I don't think this is one of Roz's because I don't think it was impressive enough to be, so but yeah, let's go take a look. All right, this is definitely one of the gullies that Roz worked in. I bet her soil pits, I think she filled in her soil pits, but they've also probably been covered over. This one's a little bit unique because it's big enough that it actually gets a little bit of flow in the bottom. So if I scroll around here, that dirt patch that looks like a path is actually kind of the bottom of a creek that was probably running when it was raining last night. So it's kind of a little intermittent stream. It's not a true stream, but you know, we have enough area here to collect some water in the bottom. So if I look around, there's the left wall. So a lot of erosion from way up there. And there's the center. And then up the other wall on the other side is pretty big too. So let's walk up to the head of it and just see what we can see here. And you can kind of get an idea of what these things look like. All right, so we're kind of at the head of it here. There's a bunch of trash up there, which is very classic for these gullies, right? So these gullies probably started to form, according to Roz's dates, in the late 1700s. And so they're the low point in the topography for the next 200 years, including during a large period when waste disposal wasn't amazing in this area. And so people just threw garbage down into the holes that were behind their houses. And so these were almost inevitably the holes that were behind their houses. I think this is the spot where Roz was digging, and about 30 centimeters down, she found pretty modern garbage. So there's still probably some garbage coming into this, either from a storm sewer or from individuals, or it's getting reworked. But when I look around here, the one thing I want to point out to you, because when we're talking about legacy sediments, either at the other site or in the Dearman and James paper, look how much material has to come out of here. I mean, that wall is now 4 meters up, 5 meters up, and this one's more, right? And we read the Trimble paper, and it talked about a foot of soil loss everywhere. So in addition to the foot of soil loss everywhere, we're also eroding these. And Roz found dozens and dozens and dozens of these just within our little area here. So you add all those together, and we're talking about huge amounts of sediment that we're moving. And so in that context, those legacy sediments that are downstream, they're down that way towards the Rocky River, can't be too surprising because they had to go somewhere. And some of them flowed out into little alluvial fans, and that's what Roz dug on. But other ones must have gone all the way down and gotten to the river. And when they got to the river would have reworked them until it couldn't, and then it would have dumped them up on its banks. And that's the legacy sediments you see in Dearman and James, and those are the ones we were just looking at too. Pretty cool spot though. A lot of activity here in the last 200 years. I mean, there's parts of the world where this much geomorphic activity might take thousands of years. I'll poke around for a couple more minutes and see if there's anything else to see here. There's actually one in here too. It's harder to see. You kind of come around it right through here. In about a month, this will be easier to see, because you can tell that the whole thing with this one is that it's completely covered in kudzu. And let's walk up a little bit. In my experience, this is not a coincidence this is covered in kudzu, because I think probably 50 or 60 years ago, people noticed these gullies eroding on their property and they wanted to stop them. And so they planted a plant that turned out to be an invasive species that they thought would stop soil erosion. And that plant is kudzu. And so we can barely even see in there, seeing through the gaps here to see this one, because it's so covered in kudzu that it's barely even visible. And that's not a coincidence. So if you drive up and down 115 Main Street in Davidson and you see patches of kudzu, in my experience, if you look around, you will then immediately realize that there's a gully underneath that. So, and then on the other side, we have a huge one. It's almost a valley at this point. And this may have pre-existed a little bit. There may be a little valley, but my guess is that if we get to the top of it, there'll be a much newer looking gully head to the top of it, even if the main part was a pre-existing valley. Keep walking. So I've been following the little trail that follows this gully, but up on the ridge line. And so we're finally way up at the head of it. So here we go. You know, kind of steep down in there. Like I said, some of this valley might have pre-existed, but probably not that deep. And then right at the head of it, which is hard to see through the trees there, right at the head of it, you see there's a huge drop off with kind of a big head wall to it. So definitely still getting gully forming processes at the heads of these valleys, even if the valleys might have pre-existed at some point. Okay, so we're actually in the upper part of the valley above where that gully is. And so this is actually a great place to look at process, because look, this valley did pre-exist, and that's what it would have looked like, a little stream. And then if we walk a little bit down here, and it's gonna be hard because there's actually water in it, look at the drop off there down in. And I think if we walk to the side, we can probably get a pretty good view of what that drop off looked like. And so you can see how kind of the normal topography would kind of collect water, but then some of these gully formation processes would have taken a little more. Whoa. So there's kind of where the stream is now. And there's the little head wall. What a big drop that is. It's got to be a 4-meter drop there, and it's kind of undercut in exactly the same way we've looked at in some papers. So good way to look at how processes can kind of combine to get what we end up seeing. So here are the uppermost heads of these gullies. And if we look across kind of this is a power line easement here, and so it's cleared so we can see a little bit better. But here's the uppermost part. So guess what the vegetation is for all these, including the one that looked kind of natural still. It's all kudzu, right? So someone came through here, said, oh, we got some erosion problems, planted a little bit of kudzu. And that kudzu is aggressive and strong, and especially in a power line easement where it has plenty of sun, it can expand, and then it'll climb the trees. And when it climbs those trees, it'll eventually kill the trees and it'll expand that open patch even more. So yeah, you can really tell what kind of topography it thrives on here. So, all right, I'm almost back to my car. I think that's it for today. There's a big mountain bike jump behind me. It's hard to see this time of year, but these were all built in the last couple of years, and in the winter they are bare and you can see them. It's all closed right now, but there's the launch. It's a big step up onto that. So all right, we'll get this posted. Talk to you guys soon. Later.